In this presentation, I will be walking through two problems that focus on different aspects of algebra. The first problem I am going to work through is a multi-step word problem involving multiplication. The problem says, Peter has 4 horses. Each one eats 4 pounds of oats twice a day. How many pounds does he need to feed his horses for 3 days? To solve this problem, we must multiply the number of horses Peter has by the amount of food that is needed twice a day. If we do this, we come up with 4 horses times 4 pounds of food times 2 because they are fed twice a day. Following the rule of PEMDAS, we must first solve for what is in the parentheses. This leaves us with 4 times 8. Next, we multiply 4 times 8 together to get 32. This tells us that 32 pounds of oats are needed to sufficiently feed Peter's horses. But we aren't done yet. We need enough food for 3 days. Since we know that 32 pounds is needed a day, we can multiply 32 by 3 to find out how much food is needed. To multiply this, we start with multiplying 3 times 2 to get 6, and then 3 times 30 to get 90. The answer results in 96. 96 oats are needed to feed Peter's horses for 3 days. Some ELL accommodations for this specific problem could be the following. The use of manipulatives might aid with visualizing the problem and how we get from the beginning of it to the final answer. You could help aid them in finding the key information in a word problem. Or you could begin with similar problems to this one. I would probably put this caliber of question towards the end in hopes that it is challenging but doable. This problem asks to find the rule in the missing outputs for the input-output table below. To do this, we must look at the given inputs that have coinciding outputs and figure out the relationship between them. In order to solve for the unknown outputs, we have to find the rule first. First, let's look at the input 90 and its output 10. We see that 90 is greater than 10, which means that our operation has to be either subtraction or division, because those operations will provide us with smaller outputs in this case. Let's start with subtraction. 90 minus 10 equals 80. Now let's look at division. 90 divided by 10 is 9. Now that we have this data, let's look at our other known input and output, 27 and 3. Starting with subtraction, we get 24 when taking 3 away from 27. Since 24 doesn't match any of our data from our first input-output set, let's move on to division. 27 divided by 3 is 9. We now see a common pattern in both outputs. Our commonalities are 9 and division. Let's use these to come up with a rule. The rule becomes x divided by 9 equals y. We can now use our rule to solve for the missing outputs. Let's start with plugging in 54 as x in our rule. 54 divided by 9 is 6. Looking at our next input of 108, we might need a little more help. Let's divide this out. 10 divided by 9 is 1. 1 times 9 is 9. 10 minus 9 is 1. Bringing down the 8, we are left with 18. 18 divided by 9 is 2. That makes 12 our output for 108. For this problem, you could provide the times table for your students who are struggling. Another element that this problem has is that the directions are short and simple. This allows ELL students to understand exactly what their task is.